Okay, I am going to do a problem that's found in your book. It's concept 14.2 and it's found on page 271 and it's number 3. This is probably as hard as a problem as I will give you for this, and this is part of the section solving complex genetic problems with the rules of probability. Essentially what this is taking a very hard Punnett square cross, such as a trihybrid, and turning it into a somewhat simple problem just by using some relatively simple math. So this problem says, number 3, what if 3 characters, flower color, seed color, and pod shape, are considered in a cross between 2 pea plants? And these are the 2 pea plants. Heterozygous at flower color, big P, little p. Heterozygous at seed color, big Y, little y. Heterozygous at pod shape, big I, little I. And that's given. And that's crossed with an individual that's homozygous recessive at flower color, so that would be a white flowered plant, with yellow seeds, which is heterozygous for seed color, and homozygous recessive for pod shape. So this plant would look like purple flowered, yellow seeds, inflated pods. This one would look like white flower, yellow seeds, constricted pods. What we're going to see is the question asks, what fraction of the offspring would be homozygous recessive for 2 out of the 3 characteristics? So let's see how we would do this. The first thing that we are going to do is make simple Punnett squares for each one of these crosses. So I have big P, big Y, big I, crossed with little p, big Y, little I. So I'm going to make a simple Punnett square for each one of these traits. Big P comes from right here. Little p comes from right here. And I'm going to write 1/2 will be heterozygous, and that would show dominance, which would be purple flowers, and 1/2 will be little p, homozygous recessive. Then let's do it for seed color. Big Y, little y, I get that from here, and big Y, little y, I get that from there. Let's do a simple Punnett square. So 1/4 will be big Y, 1/2 will be big Y, and 1/4 will be little y. And then the last characteristic was pod shape. Big I, little I. Do a simple Punnett square. So 1/2 would show big I, which would be inflated pods, and 1/2 would show little I, which would be constricted pods. Now, what the question asks is what fraction of the offspring would be homozygous recessive for 2 out of the 3 characteristics. So we have to figure out all of the crosses for which would show at least 2 homozygous recessive. So let's start out with the first one, which is flower color. We could have little p, and we could have, and from this one we could have little y, and from this one we could have little I. That would show 3 out of the 3. What percentage out of this one is little p? Well, it is 1/2. Out of this one, what is little y? It's 1/4. And out of this one, which is little I, it's 1/2. So that would be 2 times 4 is 8. 8 times 2 is 16. 1 times 1 times 1 is 1. So 1/16 would be like that. Let's see what it would look like if we had little p's, little y's, and then big I, little I. Okay, so that would be 2 out of the 3. So little p would be 1/2, little I would be 1/4, And big I, whoops, that's an I, not a T, by the way. Big I, little I would be 1/2. So that's 1 times 1 times 1 equals 1. 2 times 4 is 8. 8 times 2 is 16. Okay, so we got 2 done. Now let's see, what else could we do? We could do little p, little p. We could do little I, and let's use big Y, big Y. That has 2 out of the 3 are homozygous. Oh, my dogs are going to bark because the cats are fighting. Shush, guys. We'd have little p would be 1/2. Big Y would be 1/4. And little I would be 1/2. So that'd be 1 times 1 times 1 is 1. 2 times 4 is 8. 8 times 2 is 16. There's another one that would be little p. Let me make sure I'm still on. Big Y, and little I. That would be another cross that would have 2 out of the 3 homozygous recessive. So little p is 1/2. Big Y is 1/2. And little I is 1/2. So that would be 1 out of 2 times 2 is 4. 4 times 2 is 8. Is there any other ones that we can do? Let's see. Oh, we could do, we could do big P. Whoops, big P, little Y, little I. That would be 2 out of the 3. So big P, little p would be 1/2. Little y would be 1/4. And little I would be 1/2. 1 times 1 times 1 equals 1. 2 times 4 is 8. 8 times 2 is 16. So, did I catch all the ones that would be at least 2? We got that one, that one, that one. I'm going to cheat for a second. I believe that is it. You guys can correct me if I'm wrong. Now, we have to change all of these to reflect our denominator was 16. So we have to change 8 to 16 to do that. We take that times 2. We have to take the numerator times 2, so that's 2 over 16. So let's add all of these together. 1/16 plus 1/16 plus 1/16 plus 2/16 plus 1/16. 1, 2, 3, 4, 5, 6. 6 out of 16. If we, let's see, we can divide that one by 2. Divide that one by 2. That would be 3/8. There you go. So, therefore, what fraction of the offspring are predicted to be homozygous recessive for at least 2 out of the 3 characters? It would be 3/8. There you go. Have a good night.